Question 24. Jack intends to deposit $80 into a savings account on the first day of each month for 24 months. The interest rate during this time is 6% per annum, compounded monthly. Part A. Calculate how much money Jack will have in his account at the end of 24 months. Jack will be depositing $80 per month over 24 months. This means the first deposit of $80 will be in the account for the full 24 months, earning interest. The second deposit will be in the account for one less month, so it'll be in the account for 23 months. So it's only going to earn 23 months worth of interest, and the pattern continuing for 24 months in total. Now we can model this using a geometric progression. We'll do that shortly. But firstly, we need the interest rate per month because the interest rate quoted was the interest rate per annum or per year. So to get the interest rate per month, we take the interest rate per annum, 6%, and we divide that by 12, and we get 0.5% or 0.005 as a decimal. So to get the future value, that's the amount in Jack's account at the end of 24 months, we use the following expression. We have $80 and we're going to increase that by 1.005 and we're going to raise that to the power of 24 because it's going to happen 24 times. That's that first deposit of $80 that's going to be in the account for the full 24 months. Then we're going to add on to that 80 times 1.005 to the power of 23 and so on until we get to the final month. So we're going to plus 80 times 1.005. So the last deposit of $80 is only going to earn 1 month's worth of interest. Now we can factorize out 80 and 1.005 from all the terms of this geometric series, and we get future value is equal to 80 times 1.005 times, open bracket, 1 plus 1.005 plus 1.005 squared plus ... plus 1.005 to the power of 23. So what I've done is I've just switched the terms around. So the term with the highest index or highest power now is at the end. Just makes it a lot easier to see. Now what we have here in brackets, so the last bracket here, this is a geometric series. First term A is 1 and a common ratio of 1.005. That's the R variable in the sum of a geometric progression formula. So future value is equal to 80 times 1.005 times 1 minus 1.005 to the power of 24, since there are still 24 terms in this series, over 1 minus 1.005. So that's the formula A times 1 minus R to the power of N over 1 minus R. And that evaluates to 2044.729201 and so on. So we need to round that to 2 decimal places because it's a money amount or a value in a bank account. Therefore, Jack will have $2,044.73 in his account at the end of 24 months, correct to the nearest cent. Part B. A table of future value interest factors could have been used to calculate how much money Jack would have in his account at the end of 24 months. Part of the table is shown. What is the value of A in the table? Give your answer correct to 3 decimal places. The table shown gives us the future value of an annuity of $1 per period over a number of periods for a given interest rate per period. Now from part A, we know that Jack deposits $80 per month over 24 months at 6% per annum, but it's 0.5% per month. And we know that the future value, or the amount in Jack's account at the end of 24 months, is $2,044.73. Now to work this out, I'm going to use the unrounded future value, that is 2044.72920. We know that this is based on an annuity of $80 per month. But the table is based on an annuity of $1 per month. So if we take this value here, which we found in part A, divide that by 80, we get the value of A that we want in the table, which is 25.559115. How we can interpret this value is if we deposit $1 per month over 24 months at 0.5% per month, compound interest, the future value of that would be 25.559115 or $25.56 correct to the nearest cent. Therefore, A is equal to 25.559 correct to 3 decimal places.